All right, today we are taking a trip way, way out there, about 4,100 light years away to be exact, into the constellation Sagittarius. We're going to check out one of the absolute jewels of the night sky, Messier 20, better known as the Trifid Nebula. And I'll tell you what, as peaceful as it looks, its beauty is hiding a surprisingly violent past. I mean, just look at that. It's incredible. You're looking at a stellar nursery, a place where brand new stars are being born right now. But this picture, it's also a crime scene. So today, we're going to be cosmic detectives. We're going to use these visuals to peel back the layers and uncover a really dramatic story of a cosmic collision that's been hiding in plain sight this whole time. Okay, so first things first. Before we start looking for hidden clues, we've got to understand what we're actually seeing. M20 is super special because it's like a cosmic sampler platter. It shows off 3 different kinds of nebulae, all packed into one location. So first up, you've got that incredible reddish-pink glow. That's what we call an emission nebula. What's happening is there are these really hot, young, massive stars buried inside that gas cloud, and their powerful light is basically zapping the hydrogen gas around them, causing it to light up, kind of like a giant neon sign out in space. Then you have that brilliant blue area. That's a reflection nebula. In this case, light from those same hot stars is hitting a big cloud of interstellar dust. Now, these tiny dust grains are just way better at scattering blue light than red light. It's actually the exact same reason our sky on Earth is blue. So the whole cloud seems to glow with this gorgeous reflected blue light. And finally, you see those really dramatic dark lanes? The ones that seem to carve the whole nebula into 3 pieces? That's an absorption nebula. And it's actually how the Trifid got its name. These are just incredibly dense, cold clouds of dust that are so thick they completely block the light from that glowing red nebula behind them. So you put it all together, and this is the picture you get. You've got the glowing red emission gas, the reflected blue from the dust, and those dark absorption lanes cutting right through it all. Emission, reflection, and absorption, the whole shebang, all in one magnificent object. Pretty cool, right? But, this just leads to another question. What in the world is going on inside those dark, dusty lanes? The light our eyes can see, what we call visible light, well, that only tells part of the story. To really see what's happening, we need to look at the universe in a whole new light. Right, so in the normal view, those dark dust lanes are like solid walls. You can't see past them. But if you switch to infrared light, everything changes. Telescopes like the Spitzer Space Telescope can actually see heat, and that cold dust that was blocking our view, it gets warmed up just enough by nearby stars to start glowing with heat in the infrared. And that lets us peer right through the veil. And here it is. This is the infrared view from Spitzer. Wow, it totally flips the image on its head, doesn't it? All of a sudden, those dark lanes that were hiding everything are now the brightest parts of the picture. They're glowing with heat, and they're revealing the secrets they were hiding. Entire nurseries of brand new baby stars just starting to form. So when astronomers got a good look at this infrared data, they realized the material isn't just some random blob of gas. No, it's actually organized into this complex network of long, dense structures they call filaments. And then dotted all along these filaments are even denser clumps called cores. These are literally the construction sites, the building blocks for the next generation of stars. And the scale here is just, it's mind-boggling. Take a look at that filament named WF. It stretches for almost 12 parsecs. To put that in perspective, that's over 70 trillion miles long, and it contains more than 2,300 times the mass of our sun. These are absolutely colossal structures we're talking about. So this brings us right to the heart of the mystery. You see, the entire Trifid Nebula is being lit up by one absolutely massive, brilliant star called HD 164492A. But stars that big don't just, pop into existence. Something truly energetic had to have happened to create it, and all the clues point to a story that involves not one, but 2 colossal clouds. Okay, so here's the key piece of evidence that really had astronomers scratching their heads. When they measured the gas in the area, they found 2 very distinct clouds. But, and this is the important part, they were moving so fast relative to each other that there was no way gravity could be holding them together. Something else, something way more dramatic had to be going on. This is the speed that changes everything. The 2 clouds are moving relative to each other at 7.5 kilometers per second. That is over 16,000 miles per hour. This isn't some gentle cosmic dance. No, This is the unmistakable signature of a high-speed collision. And here are our two suspects. On the left, you have what astronomers call the 2 km/second cloud. On the right, the 9 km/second cloud. They're both huge molecular clouds, and their temperature shows they're both right there in the nebula. But they're in different spots and, crucially, moving at very different speeds. The only explanation that fits all the facts? They smashed into each other. Okay, so if there really was a giant cosmic crash, it should have left behind some clues, right? Some fingerprints. And that is exactly what astronomers found when they started comparing what they were seeing in the sky to computer simulations of what these collisions should look like. They looked for 3 key fingerprints. First, something called a complementary distribution, which is just a fancy way of saying one cloud looks like it has a dent in it, and the other cloud fits perfectly into that dent. Second, bridge features. This is gas that got caught in the middle of the crash, and it's moving at a speed somewhere between the 2 main clouds. And third, the high temperatures, which we already knew about, proving they're physically close to each other. And here it is. This is the big aha moment. On the left is a computer simulation showing what a collision between a small cloud and a big cloud should look like. See how the small one carves out a cavity in the larger one? Now look at the right. That is the actual radio telescope data from M20. The resemblance is just undeniable. The model perfectly matches reality. The red cloud fits right into that gap in the blue cloud. It's a perfect match. But wait, the evidence gets even stronger. The simulation on the left also predicts that if you were to analyze the light coming from that collision zone, you should see this very specific bridge feature. See that little bump of gas connecting the 2 main peaks? Well, look at the right. That is the actual data, the real spectrum observed in the Trifid Nebula. It's not just close, it's a perfect match. Case closed. So, with the fingerprints confirmed and our suspects identified, we can finally reconstruct the event. We can tell the story of how that massive star at the heart of the Trifid Nebula wasn't born gently in a quiet nursery. No, it was born in fire. And it happens in 4 stages. First, you have a smaller cloud hurtling towards a larger one at supersonic speed. Step 2, they collide. This smash-up creates a shock wave that forms an incredibly dense, compressed layer of gas right where they meet. Third, the immense pressure in this layer makes it unstable, and it fragments into dense clumps. And finally, one of those clumps gets so big, so massive, that its own gravity takes over, it collapses, and boom, it ignites into a massive new star. And so, that is our verdict. The stunning, serene Trifid Nebula we see today was actually forged in violence. About 300,000 years ago, 2 massive clouds of gas and dust collided at over 16,000 miles per hour. And the shockwave from that crash is what triggered the birth of the giant star that now lights up the entire region. You know, it really leaves you with a fascinating question. We tend to think of creation as this peaceful, gentle process. But the story of the Trifid Nebula shows us it can be incredibly violent, incredibly chaotic. And it really makes you wonder, just how many of the other brilliant stars we see lighting up our universe were also born not in some quiet nursery, but in the heart of a truly epic cosmic crash.